Thank you. Well, thank you very much, Angelica, for that very kind introduction and reminding how old I am right at the end, how long ago my PhD was, if I remember it. But yes, it's a real pleasure to be here. I'm very appreciative of having this opportunity to talk here in the Senckenberg Museum for many different reasons. I have been in this room a couple of times in the past because the museum is such a strong supporter of IPBES, which we're very grateful of. I've been here for two assessment meetings, including 2 years ago, standing right here when we were starting the Nexus assessment, which is coming out at the end of this year. Now, as Angelica's introduced me, I'm a coral reef scientist, and my own science background is in coral reefs. In a big way, I'm coming out of that in terms of trying to from an understanding of what's happening with coral reefs, getting this message out to the broader world because of all the changes that are needed. And one of the things I felt in the last few years would say, if we save coral reefs, we save everything else, because they're so vulnerable to climate change that just by dealing with that stress, of course, you turn down the pressure on all these other systems that we're all working on. I will focus more on the broader sustainability science. I'll give an example from coral reefs in the middle. I've put the items I've selected for this cover slide are, well, this picture from the New York Times magazine, I mean, that was a real surprise. There was an article on scientists watching their systems disappear. And from interviewing for that, my picture is the one that ended up on the cover. But I think it was really because I emphasized that while it is, of course, very depressing and very distressing what's happening, is from an African perspective as well, I feel we need so much to identify the right things to do to stop the amount of change that's happening. We need to point very specifically in the right directions at what needs to change. And so I'll talk about that. I have 3 institutional backgrounds I've identified here, and I'll draw from each of those in various ways, and I'll try and show that. But really coming to a perspective around the need for balance. And so in the title, Balancing Nature, Economy and Society, that's the sustainable development paradigm. But focusing at local scales and making it work at local scales, because nature and people's experiences happen locally, and you need to expand out from that. So with that, I'll head into this, and I hope it'll be an interesting ride. So in this talk, I'll have 3 main topics. So talking about nature, economy, and society, and I think how IPBES's conceptual framework and the sustainable development paradigm really come together very well. As the chair now, my sort of mission is to understand how do we communicate from the science of IPBES and our findings to the relevant people, to decision makers at all levels, whether it's from local to global levels, the urgency of the decisions that are needed. Coral reefs are a great flagship ecosystem, the canary in the hothouse now, perhaps we should call it, rather than the coal mine. And then I'll go into the systems approach, but pointing to the need for integrated actions. It's not enough just to do science or just to do conservation, because the drivers all come from economy and society, and we really need to work out how we have integrated actions across those. So I'll try and go through those. Now, the first example here, or the first slide, is just showing you IPBES's conceptual framework. The science that we're a science policy panel. We do synthetic science, looking at all the knowledge that's out there and how do we bring it into a common framework of understanding. So we invested a significant amount of effort in the first years of developing a conceptual framework from all the knowledge that is out there. It's a very complicated framework of boxes and arrows. There are 6 main boxes there and 10 numbered arrows. There's a slightly simpler depiction of that framework that has been used in multiple assessments now, and really tracking in a very understandable way how we go from nature through its contributions to people, how they support our good quality of life, the institutions and governance and anthropogenic assets we use that also sort of determine how we use nature, so indirect drivers, imposed direct drivers, and back down through nature over there. The second major piece of framing that we identified right from the beginning was to really generalize out from the understanding of ecosystem services, from the Millennium Ecosystem Assessment, to nature's contributions to people. The intent there was to really show that there's much more than just the monetizable or the quantifiable services from goods and services from nature that scientists like to work on, but there's many cultural benefits, many psychological benefits as well. We identified 18 classes of contributions from nature. This table is from the global assessment that came out in 2019, and it showed how basically all of the both biodiversity as a whole, also the contributions from nature, are almost all declining, except for the ones that we focus on in our economic systems. So food, energy, and materials, where we explicitly maximize production of these from nature for specific economic sectors. And in fact, it's that maximization of those benefits that is undermining the production of all the other benefits. And so realizing that this maximization focus and narrow focus is really the problem. And we won't generate solutions by going further along the lines of the same sort of frameworks. And we've used these frameworks to organize all of the work in all of the assessments that we have done from, I think, 2016, the first assessments that came out, to the present. The global assessment in 2019 was our signature one. Now we're working on the Nexus and transformative change assessments. I'll talk about those later in the talk. Business and biodiversity will come out next year. And then we have 3 or 4 more assessments to produce between now and 2029, which we're setting up and working out what those will be. A second global assessment to come out in 2028. So that'll be a big piece of work when we get to that. Now, but this conceptual framework is also a bit complicated for many decision makers. Even with 6 boxes and those arrows, how do we make that real for people? And I've worked a lot with the Sustainable Development Goals over the years, and also as the chair of IPBES, we're talking to governments. So governments are interested in the frameworks that they have already agreed on to understand any new inputs that come in. And the Sustainable Development Paradigm is, of course, a critical one for all governments. And so as looking at how do these relate, how can we talk about this conceptual framework in the context of nature, economy, and society together? And of course, these developed at the same time. So it's perhaps not a surprise that there's actually very close association between these 2 frameworks, and perhaps they're just, in a way, synonyms for one another. They're alternative ways to look at the same issue. So nature is the same. That's in the IPBES conceptual framework. The nature's contributions to people are what we take from nature into our economies, and that's those food, energy, and materials that we've been maximizing over time. Societal benefits, the support from NCP to good quality of life. That's a bit more complicated, but that's contained in that arrow of societal benefits up into society. The indirect drivers and the governance and the choices that we make, different cultures and their perceptions of nature, those are how societal values affect how economy is undertaken in different places. And then economy is, the economic activities are put the direct drivers on nature that are causing its decline. So there's very close correspondence between these 2. And I think we can really use them as alternatives. And one way to really help get the IPBES message out into more political context is to use a sustainable development language a bit more than the IPBES language, perhaps. The Sustainable Development Goals, of course, are more detailed sort of disaggregation of that nature, economy, society. And I'll talk about that a little bit. I've done a lot more work on that, but I won't go into that much in this talk. But in thinking about how to really strengthen this model, so systems model approaches, I think coming back to that, because this is in the origins of the Sustainable Development Paradigm. Donella Meadows and various of her colleagues, these are the authors of the Limits to Growth publications in the 70s, and some of the original thinking on sustainable development. And in systems approaches, you think about nodes, the linkages between those nodes, and then the overall system purpose in what moves forward. And I'll come back to this a little bit more in coming slides. Now, the urgency of action, I'd like to highlight just 2 here, illustrate them. One is on the state of biodiversity and biodiversity trajectories. And this shows, we've been focused very much on shifting baselines in the past. Now there's a lot of thinking about trajectories into the future, which I think is correct. But we need to work out how to move from the very complex scientific sort of models and trajectories into the future. simplify them down with communication materials so they can be really talked about more. But then going to more campaign-oriented approaches can be problematic, and I will explain a little bit more about that as we go along. Just to establish the basis on these trajectories into the future, this is one of the graphs I just showed, and a really good simplification down to the three main sort of projections into the future. So business as usual, the gray line at the bottom, the yellow line is if you did all conservation and restoration actions, fully achieved the HE targets, and now the Global Biodiversity Framework would achieve that yellow line. And if you add on to that all of the right sustainability actions and production and consumption processes, that green line would basically get back to above the baseline for these models, which was 2010. That green line gets back above the baseline by 2100, but even the yellow line doesn't. Even all the conservation restoration actions we would do can't keep biodiversity as healthy as it is back in 2010 initially, but also if you see where we are now in 2024, we're basically somewhere between the yellow and the gray lines over here, because we're doing better than business as usual, but we didn't achieve any of the HE targets, so we're not at the yellow line either. Another study came out this year that provides a really good foundation for this, because this really looked at how effective have conservation actions been. If there are no conservation actions, you could imagine this red line as just a hypothetical one. But in Langhammer et al., they identified that perhaps 45% of conservation actions have a net positive effect, so it would be the equivalent of the green line in terms of making the biological system better than it was before. 21% reduced the amount of decline, so it didn't maintain the same state, but not as bad as if it hadn't been done. And about 1/3 altogether, either no effect or a net negative effect because of various different reasons. So basically, if you consider where we would be with how we're working now, projecting out into the future would be somewhere along between the yellow and the gray lines over here. But it's very hard to see the difference right now. And this is, of course, the challenge with conservation, is that the impacts don't really become apparent until very far into the future. So actions on nature are critical for us to invest in, but they're not enough. The second thing about urgency of action is about planetary limits and overshoot. Now, you had Johan Rockström here not too long ago, I think, so I won't go into this in any detail because nobody can explain it better than he does. But of course, we're very aware now of all these various variables of the Earth system showing how much we're overshooting our planetary footprint. The one that's most interesting to me is the biosphere one over here, and I'll come back to it a little bit later in the talk. But of course, with temperature increase and the 1.5 degree limit, which was identified as a safe limit through the IPCC processes, of course, we're blowing through that so quickly. CO2 emissions are not being brought down. It's, of course, very hard to communicate the degree of variation there is in all of these things. So we're at about almost 1.3 degrees of warming on average right now. Almost reached 1.5 degrees in the last 12 months. But this 1.5 degree limit is really a 20-year average that the IPCC has identified for establishing, what this index is. So you don't even know you've passed it until perhaps 10 years later when you look back at the average of the temperature. So there's a lot of problems there, and yet we only have 5 years left to consume the CO2 budget that would enable us to remain below 1.5 degrees warming. So all sorts of challenges with urgency there that we need to be very conscious of. To make it more tangible, because of course planetary boundaries are very intangible for many, this is the update, the health check. They published this just last week, I think, for New York Climate Week. You look at where the various, of course, green is safe and yellow to purple is very unsafe. We keep thinking about temperature and all of these climate and physical variables, but if you look at all of the planetary boundaries that have far exceeded safe levels over here, they all have a huge, either they're biodiversity variables, so you have genetic diversity, functional integrity down here, or else like phosphorus, nitrogen, or novel entities, that's pollution, they have incredible impacts on biodiversity in nature. So all of the planetary boundaries that are most above the safe levels all have very high impacts on nature and biodiversity. And I think that's just not really sort of talked about or understood well in the public domain or in the policy world. I think this needs to be communicated a lot better. And I think there are other tangible indicators like this as well. I think this is one of the craziest sets of statistics that I've seen. If this is not a sign of how unbalanced the world is, I don't know what is. So this is the figure from 2018, a paper here, the biomass of all mammals, mammalian species on the planet. There are something like 6,500 species. Of all of those, so all the land, wild land-based mammals, about 6,300 species, that's 2% of the total biomass now. Marine mammals, because whales are so big, there's only 130 species, but because baleen whales are so big, even though they've declined so far, they're 4% of the total mammalian biomass. But of the rest, about 38% of the biomass is us, and about 58% is what we eat, and some of our pets as well. And that we have shifted the mammalian biomass so far outside of any conception of what is natural or could be a balanced system is, I think, is just an incredible planetary boundary that has been breached and needs to be returned if we can. How we do that is something else. So, having talked about the urgency of action, I'll go to the example from coral reefs. Let me just take some water. So I won't give background on coral reefs, on how valuable they are and so on, because I think we hear that a lot. I used this image of the Sustainable Development Goals and a coastal area. This is on the coast in Zanzibar, I think, from this picture, quite a lot, because I think we can really see the essential nature of the Sustainable Development Goals, the interactions between them, by looking at local spaces. Many people, companies or cities or the public, feel that the SDGs are very remote. You know, they're negotiated in the United Nations system at the national to global level. But really, they describe sustainable living across the 17 goals. And I think emphasizing this is really important. But what's happening in coral reefs right now that is upsetting this system? This is the graph from the Global Coral Reef Monitoring Network, the global report published in 2021, so data up to about 2020. And you can see that the global coral cover is the line in blue with error margins around that, narrowing in more recent years because we have much better data. And the black line shows sea surface temperature increasing over that same period, the anomalies. And the red lines are basically either very rapid increase in temperature in dark red or long sort of sustained increases in light red. The global coral reef bleaching events we've identified are numbered sort of 1, 2, 3 up at the top. Number 4, initially, I first put this graph together about a year ago. We had just been started through a very extreme high temperatures in the Caribbean at that time, in the Atlantic. And there were question marks about whether this would become the 4th global bleaching event, which was confirmed in April this year. I think an announcement came out that we've confirmed that. So the question now, and the GCRMN is putting together a new report for 2021, and we're trying to see, so what has been the change in coral cover since about 2020 up until now? Has it gone up? Did it stay stable? And then how much has been lost in the period since sort of this time in 2023 until now? And I'm pretty sure it won't be a very good story. This graph shows how bad temperature has been in the ocean during this period. The Copernicus satellite system from the European Space Agency has producing these wonderful graphics. And I think this is one of the scariest one from the last year on global warming, because this shows sea surface temperature from 60 south to 60 north. And you can see all the squiggles from, I think, if I look here, it's a bit easier maybe, from I think 1970. And you can see year on year, there's been an increase, but all the lines interlace with one another. Even the recent hot years, the lines are going up and down. But since May or June last year, the ocean has been hotter by an incredible margin above any temperatures that we've recorded in the last 50 years, which of course are much warmer than the previous years that we have any records from. And that, of course, this goes up to May this year, but of course it's been quite similar for the last few months over the northern summer. So this is a real change in global heating, I think, and one that will be of very high significance for coral reefs. This is what we have from the IPCC, the burning embers that we have all become so familiar with, and this limit at 1.5 degrees warming of 10 to 30% coral reefs remaining after that, and then only 1 to 10% remaining above 2 degrees. There's a lot of argument and debate amongst coral scientists about what do you mean when you say only 10 to 30% remaining. Of course, there will still be corals in many reef areas. The more resistant species will survive. There's some adaptation. But in terms of the full ecosystem persisting and being able to maintain itself is significantly undermined, and the regionally connected coral reef systems that we've known until now are being broken up into scattered, isolated systems. And so the IPCC will not know for maybe 10 years whether we have hit 1.5 degrees or not, but it's clear that we've really hit a critical point for coral reefs now. I had a slide on coral reef tipping points, but I took it out just because of time. And what we did in the Global Tipping Point report put out at the end of last year, 2023, at the Climate COP, was we pulled down the critical band for coral reefs was set at 1.5 to 2 degrees before. In that report, we pulled it down to between 1 and 1.5 degrees, with a median at about 1.2. And so we've already passed that critical point for coral reefs. And of course, probably for other sensitive ecosystems that are less well known as well. Of course, it's very similar for mountain systems and for Arctic ecosystems as well. Now, this is very important, of course, a focus I've had a lot being based in Africa, and because there's so much work on protected areas and the best biodiversity areas, has been much more focused on, well, what about not the best areas, or what about the areas where people are living and the systems are quite degraded, but they need still to function and support people's livelihoods. So that's the whole nature's contributions to people aspect of IPBES. So we've focused a lot on community dependence on reefs and co-management. How do we try and promote better management in these areas where reefs are declining because of fishing and local pollution and coastal development, but also because of climate change? So it's very clear, I think, in many of the countries that the only real sort of prospects for better or good management in the future is community or co-management, where communities and government have shared responsibilities. We call these locally managed marine areas. There are many different terms that are used around the world, in the Pacific as well. And then in the Convention on Biological Diversity, this term other effective conservation measures has come in. And I think there's a lot of power in that approach to really ramp up interests in communities to conserve. But they need their interests to be recognized as well. And that's a real challenge. It's a bit of a conflict and a tension in the conservation and biodiversity management space about how do you deal with people's needs and conservation at the same time. Other effective conservation measures are really identified as a system under Target 3. So this is the protected area target of the Global Biodiversity Framework. But we did these surveys with communities to see in Kenya, Tanzania, and Madagascar, we had sufficient numbers to produce some results. Is what do communities think about how their sites would be as other effective conservation measures? Do they want this designation or not? In general, a lot of them want it, but they want it, of course, to meet their needs as well for sustainable use and for fisheries rather than just conservation. I've highlighted two results here. One on the left here, a worrying one, is one of the questions, and this is self-reporting, not by the communities themselves, but by NGOs that work a lot with them. So does the site have high ecological integrity? In Tanzania, there was at least a lot of honesty there in which they said no. More than half the sites they felt had very low ecological integrity. In Madagascar, they said partially. In Kenya, we're very confident our sites have high ecological integrity. It's probably not correct. And then here, does the site meet the OECM criteria? And here, we counted up the number of responses. Most of them don't, of course, but there's a lot that, the reporters felt could partially meet these criteria, but it would need a lot of work to improve management, to improve the state of the ecosystem and things like that. So what we're hoping is that we can use this other effective conservation measure category in the Biodiversity Convention as a way to bring in more interest from communities, not just to say, do you qualify or not, but to identify their level of readiness, to identify, so what investments are needed to help bring them up to meet all the criteria, maybe over a 5-year period or 8-year period or something like that. So we have a lot of hope that this could work in a capacity development way to help improve conservation. I'll have 2 last slides here on red listing processes, one on the red list of species for corals. Now, we're currently reassessing them. It's taken 5 years. It's a long effort. Just had a conversation with your own sort of Marine Invertebrate Red List Authority team about red listing of marine species. We have, I think, so in 2008, we assessed the corals. Those were the results over there. And the red list index of change over time, this was a backcasted value from that assessment, showed very steep decline. It's time for reassessing them because that was now 16 years ago. So we've had to do 892 species, which of course is a lot to do. We've had a change in the methodology. We have now quantitative results, which we didn't have 16 years ago. So we had to recalculate the red list index as well to backcast what the status would have been back then. I can't report the results because they haven't been published yet. But we do know that the risk levels are higher than in 2008, and there's more critically endangered and endangered species than we had reported before. And there was this large band of near-threatened corals, which we had identified back in the first red listing, and also data deficient. And I think because of the better numbers and approach, we've been able to shift a lot of those. A lot of those have gone into vulnerable sort of and endangered categories. And some least concern have increased as well, I think. So these are very widespread species. So interesting results coming out. We'll be able to report on that soon. As an ecologist, I have a greater affinity for the red list of ecosystems from IUCN. I think there's a lot of power in this approach. We applied it to our region's reef, so the whole region of the Western Indian Ocean over here. And we found that 4 of our ecoregions against the continental coastline and the Seychelles main islands over here were vulnerable because of fishing pressure. But then these other island ecoregions, the reefs are all endangered or critically endangered because of future warming. They're vulnerable to that. And then now I'm sort of lead into this nature economy society. So what do we do about this? This is the challenge with coral reefs, is that the pressures are so large scale coming in, and climate change, of course, is something that you can't do anything about locally, is to identify what are some of the integrated actions that need to be done. There's been a lot of sociological systems work on coral reefs over the last 20 years now, and a real sense with fishing, it's a real wicked challenge. So I've basically just drawn all these links between nature, economy, and society, and in yellow and red is that there's so many challenges. You have to work on all of them. You have to work on them all locally as well as teleconnected out from that scale. But it's possible because you can have agency at these scales. When thinking about the threat from heating, of course, that's all indirect and direct drivers impacting on local reefs. You can do a lot around your sustainable use and so on and benefit sharing, but that doesn't affect what happens with these drivers. This is for the global community to work on, but we're not obviously doing that fast enough. But what we'd like to do, so the red list of ecosystems, that's a headline indicator in the global biodiversity framework. So in the current biodiversity plan for countries to report on. So we're really promoting its use for the countries because now they have very strong sort of policy needs to report on it. It's all very well having a final result, say for Kenyan reef. So this is data from Kenya, broken down national. So in each of these, the red list of ecosystems is based on hard coral, algae, and then parrotfish. That's a herbivore and a predator, the grouper. So we looked at across the food web. All this data gets crunched down into one result for Kenya, which would be vulnerable or, near endangered perhaps for the red list of ecosystems for Kenyan reefs. That's not very helpful for local managers. So what we're hoping that we can do is by using this headline indicator for a convention reporting process where countries will should invest in generating this indicator, can we make sure that we can use the data at a much more nuanced level? So each of these points is a site. And so a manager, whether it's at a county level, for example, in Mombasa here, the Mombasa Marine Park is the main area within that county. So that whether it's the county or the marine protected area can look at what are the results for their sites that they can make management decisions around, whether it's the coral, the algae, or one of the fish groups that needs support. So we're hoping this will help capacitize decision-making at local scales a lot. Okay, so let me pull back out from that to this nature economy society model. And this is where I'm trying to explore this space of trying to communicate about the challenges that we have, what can we do about them. So I've already talked about the IPBES conceptual framework and how it relates to this system model, sustainable development model, and I'll come to the Earth systems model that we've used in the Earth Commission in a moment. Critical to think about in a systems model, actions can be conceptualized across the whole system, and they need to be conceptualized across the whole system, but they have to be relevant. You have to really deal with cause-effect issues rather than just externalizing and putting a box around your area of interest and not looking at things outside of that. And you have to have coherence across the whole system as well. Try and establish reinforcing feedbacks for the good outcomes. And what I'll do is I'll go through some examples or illustration of actions on nature, economy, and society that I think are interesting to go through. So actions on nature. So this focuses at the bottom end of that stack, so nature and the interactions with direct users or drivers as well. This is where I think one of the Earth system boundaries, the one that I was most interested in, I think gives a big leap forward in using the planetary boundary concepts. And I think the value here is because rather than thinking at the planetary level, many of these Earth system boundaries actually occur at local levels, and you need to aggregate from the local scale up to the global rather than getting a global scale indicator and then having to downscale from that. So for the biosphere, we identified two boundaries or two variables. One is the amount of intact ecosystems. So this is, the good spaces, the best biodiversity spaces where they're remote and less utilized. We worked on that. But I think the one that is most interesting that I'll follow through on now is this second one, which is the ability of nature to provide ecosystem services locally that people benefit from locally. And so this we call the functional integrity boundary. It's based on ecological function and a range of regulating material or non-material services from the ecosystem services framework. So food provisioning, growing food, pollination, water quality regulation. There's a number that are very locally determined. And then a big aspect of the Earth system boundary framework that is not in the planetary boundaries framework is one of justice. So that, and in terms of biodiversity, justice, being able to meet the needs of each person, it requires access. So the benefits from biodiversity or the biodiversity itself has to be accessible to people. So how did we deal with that? So this is the safe and just conception that we had in the Earth Commission. So safe means there needs to be enough of this function or contribution from nature to above minimum levels to meet people's needs. Just as I just mentioned is the accessibility, which basically for many services such as pollination, insects, some pollinators may only fly a few hundred meters. And people, in many places just walk, don't have great transport, and so it has to be in a local space. So we looked at the 1 kilometer scale. So that nature has to be present within a kilometer or within a 1 kilometer pixel for people to benefit from that. We did a literature review across, huge number of papers, able to find enough data on five benefits or contributions from nature. So pollination, pest and disease control, experiences. This is psychological and recreational experiences, so green spaces in cities, for example, soil erosion and water quality. And across 3 of those, you can see that band across the middle. So within a square kilometer, if there's 20 to 25% of the right type of habitat or vegetation, that function is provided. Now, the configuration and the quality of the vegetation is something else I won't talk about so much, but of course that's important. Soil erosion needs a much higher level. That's, ground cover that protects the soil. And then water quality, that's about, riparian vegetation. So it's very, very specific configuration. But this rule of thumb is very useful. Of 20 to 25% of semi-natural habitats, I call it high-function habitat per square kilometer, you can meet people's needs and extend this across the planet's surface. So what does this look like? So I've just pulled a couple of maps out of, this is from a preprint. It's been very hard to get this specific result published. But on the left is the intactness index that we use. On the right is the functional integrity. So on the intactness side, this is the unimpacted nature, basically. So you can see across, southern and central Europe, apart from the far north in Scandinavia and Russia, there's no intact nature in those spaces. In Africa, the most intact space is the Sahara Desert. And of course, there's not a lot of different biodiversity or functions that come out of that support people. But interestingly, on the right, when you look at functional integrity, and that's, functioning habitat per square kilometer, there is quite a lot in these spaces. And it's beginning to fall below 70% in some areas across in the Sahel in West Africa, of course. But what this means is that in terms of supporting people, the story is not, of course, that nature is highly impacted in many of these spaces. And so if you're doing conservation of pristine nature, you have many challenges. If you're doing conservation and land management and water management for sustainability, there's still a lot of capacity for success in many of these spaces, and that's the importance of restoration now. As we exceed these boundaries, can we get nature back to higher levels of function to support people? It won't be the same as it was before there were a lot of people on the planet, but it can still be very high functioning, good quality ecosystems if we do the right thing. And I think thinking forward into the future, that's a very important piece to think about. Another piece of work that I did during this process with the Earth Commission and then the negotiation of the Global Biodiversity Framework, I was interacting a lot with an Africa-wide group of NGOs supporting conservation and sustainable use locally in various cultural systems. And we were really concerned about how conservation planning is done, which tends to be very top-down within our national systems and continental, and then also the global funding mechanisms. So in ramping up ambition, so this graphic is a hypothetical country. So from 0 to 100% of the national territory on the x-axis, nature is in very good condition at the left, and the dark green becomes more degraded, then turns into intensive agriculture in cities in the orange. So very little nature there. So the HE target, 17% of land under high levels of protection, assume a country reached that. If we did the 30 by 30, the target 3, the same way, we would basically try and increase the amount of protection up to the 30th percentile of the best nature in that country. But there's a lot of challenges, social, societal, and rights challenges around that. And the idea was, how about if we spread that protection across all spaces so that nature is accessible to people everywhere. Of course, as you go into these spaces, less of that nature might meet your conservation targets. But the thing is, in doing it this way, you really address local issues. You focus at the local scale, you focus on equity and people in that space because they're present to be able to determine, so what areas should we change management to increase the amount of protection or to increase restoration. You can apply scientific knowledge at that scale. We can bring it down to local scales, but then you can use the local knowledge in those spaces as well, much better in a local context than you can use aggregated local knowledge at larger scales. And if you apply this 20 to 25% semi-natural high-function habitat per square kilometer, you can meet sustainable use, and you can eventually meet conservation targets as well if you can restore natural systems. And you apply this across landscapes, so 100% of space on land and in the sea as well. So a locally focused approach to doing nature conservation and focused on meeting people's needs in order to ramp up their commitment and interest in also meeting nature's needs as well in terms of conservation in various places. Okay, so let me jump to actions on economy now. And this, of course, has many different things that could happen over here. Economy is in the middle, and there are 4 arrows coming in or out of that layer in the model. But I'll focus on 2. So first, reducing drivers. We're very aware of the great acceleration from the papers on that by Will Steffen and colleagues, part of the planetary boundaries work. There's also a paper that did the same for ocean-related drivers in 2020. And we're also very aware that many of the direct drivers, and many of these are either direct or indirect drivers in the IPBES framework in this model up here. Many of the direct drivers, such as CO2 in the atmosphere of climate impacts, are just continuing to go up in spite of all the conventions and the agreements along the way. And we're not bringing those down. And I think one of the really important things about IPBES's work is the focus on you're not going to change direct drivers if you don't change the indirect drivers. You have to change the underlying sort of values and the reasons why people are doing things. So you can't decelerate while you're still accelerating. And nobody drives a car that way, so we shouldn't drive our planet that way. This is something that the Nexus assessment, which is coming out in December this year, is really focused on, and why I was very excited about the Nexus assessment when I first saw it and wanted to join that process. So really dealing with the interlinkages, in this case between biodiversity, climate change, food, water, and health systems. And that essentially this is like a mini SDG study because each of these nodes in that model sort of relate to 1 or 2 SDGs in terms of biodiversity. And I think the real value of this assessment, of course, we can't talk about the findings of the assessment yet because it's not approved, but it really talks about, from a nature perspective, it really talks about the direct drivers and direct uses of nature in these other sectors, but it also relates to the various societal values and indirect drivers that drive those, and that this nexus, this 5-element nexus, could be extended and applied with other types of nexuses. There could be, you could include other nexus elements or sustainable development goals as well, and it becomes a generic approach or framework to look at different challenges across many different local spaces, and it's very focused on actors and local level decision making. So I think the Nexus assessment will give us a lot of really good sort of policy relevant advice and results that can be used in many different contexts. This is something new that I would really like to, I think, can again help focus on, so finance. How do we bring in enough finance to support nature, managing nature effectively? Now, in a systems model approach, so you look at each node, and each node has its own capacities and properties and so on. You can think of each node as having capital or assets that generate its function. You look at the linkages. These are the flows between those assets or those nodes. They might be material or immaterial, and the purpose of the system. And of course, the sustainable development model, the purpose is sustainability, to persist into the future and improve in quality across the whole system rather than any one in particular. And so, but there's one key element that is not in this, and I think we need to think about more productively, and that's financial capital. And when you look at this, financial capital comes from economic activities, flows up into financial capital, into, from society as well, and then it flows down into these. It's not really a separate thing. Finance really, or money really, is a proxy measure of many of the flows, between direct users and NCP and direct drivers. We can denominate many of those in monetary terms. So it's not a separate thing either. It's also embedded in this, but it's gained such prominence in the capitalist system. We need to work out how to get more financial capital down into nature, right? We need to increase the financing on nature. But I think the key challenge is that in our current system, we don't do it because we don't value nature enough. But if you look at this as a system and financial capital is one of the capitals. So what we have done is excess conversion of nature has happened, and that nature gets converted eventually into financial capital. We accumulate financial capital in our banks and, investment funds and so on. What we need to do is to reconvert this finance back into nature, because nature is what really works. It's what does work. It sustains us. It sustains the planet. So it's not about spending money on nature. It's about just, rebalancing the system and reconverting financial capital back into natural capital. So what does that mean? So thinking about finance, imagine this is the global economy, and just throwing some numbers out, and global GDP of about $105 trillion. We know that 55% of this is highly to moderately dependent on nature. We know that the nature negative part of the global economy is valued depending on who's doing it, but this particular figure is $6.7 trillion, of which a quarter of that is public. If you look at the nature positive, quote unquote, side, current biodiversity funding is $135 billion, of which overseas development assistance and philanthropy are 13. Africa's share of that is 34%. I put this together for an Africa conference a few months ago. And nature-based solutions are 200 billion, and the biodiversity funding gap has been identified at 830 billion. But of course, all of these are, 1/10 the size of that big red box, and that's what's driving the decline. And until we balance that equation, we'll never bend that curve of biodiversity. So I think it's really understanding this, reconverting finance back into nature is a critical thing. The Global Biodiversity Framework has its targets 18 and 19. Those are the amounts. Of course, they're tiny as well compared to what we need to do. So I think what's worth thinking about is sources for reinvestment. 3 ways to look at this. These aren't mutually exclusive. One is to repurpose nature negative activities and subsidies to nature positive. So that's about the red box. Another one is to look at historical carbon emissions, which I'll talk about in a moment, but also other pollution and so on. This is the classic polluter pays. If you look at the accumulation over time, you can see how much needs to be rebalanced. And pollution is a measure of externalization in the economic system. You externalize a cost means you don't pay for it. Somebody else pays for it later. If that had been paid for, nature wouldn't have declined in the same way. So the money that went into profit from that activity could be seen as an asset that should come back into nature to rebalance the system at a certain point. And that's this last one. Accumulated wealth in a way is a measure of embedded or historical extraction. If we convert excess unproductive, in brackets, from our perspective, financial capital back into essential or productive natural capital, we can rebalance this over time. And then the part that I think is really important around equity is linking finance to nature at local scales. If you have financial assets that need to go into rebuilding nature, I think now we have the digital technologies to link a pocket of nature the size of this room in a square kilometer, or many of them, with some funding from wherever that is used to help restore or manage this pocket of nature. But the pocket of nature doesn't go outside of the control of the local system. Where the money comes from gets credit for what they do, but they don't get control and ownership of that packet of nature. And I think now the digital technologies are there, and there's several different platforms that can help mediate this process. I think we need to have these discussions in the financial world to sort of see how we can link these things together. So, and then the last one, actions on society. Is the planet overpopulated or overdeveloped? And of course, they put this up to be a bit provocative. And it's important, there's been a big discourse on this for many different years, and I think it's been very distracting around overpopulation. So these graphs come from a G7 report from the G7 summit earlier this year. So you can look at the total global wealth from 1970 to 2020 and the global population, same period. Population has doubled over that time, which is a huge increase. We're now over 8 billion people, which is a lot of people and is very problematic in many places. But wealth has increased 25 times in that time. And wealth is what drives consumption. So, you can see that economic growth is a much greater driver than population in terms of global impacts from the activities that it drives. If you look at developed different economic systems. This is comparing the G7 economies to low-income economies. Similar numbers of people in each of those groups, about 700 to 800 million people, so that's good. But you can see that they have both grown they're both roughly doubled in that period from 2000 to 2020 in this. But you can see that the G7 economy is 100 times larger than the low-income economy. So again, it's not necessarily the number of people in these places that may be important, but their total level of economic activity. You can show it in more tangible ways. This graph is about excess resource use by region. So comparing the more developed regions and the rest of the global south, the yellow line down below has a very low contribution to excess use of physical resources. This is Hickel et al. In 2020. I've used this carbon dioxide graph a couple of times from the carbon inequality report last year. It shows the relative losses, emissions, and capacity to finance of different brackets of the global population. So the bottom 50%, middle 40%, and the top 10%. And of course, it's no surprise the different levels of these columns in each of those. But what is instructive from that is to really explore what that means in terms of equity in people's differential contributions. So if you look at the percent emissions, the responsibility of different groups for carbon emissions, so here we split the percent emissions in the green bars into the 10% or 10 percentile units of global population or deciles. You can see that the red bar, sorry, it's easier for me to look over here. So yes, in the green. So the green bar over here in the top 10%, basically the richest 10% of the global population produce 50% of the carbon emissions, and the rest, of course, is much less as you go down that pyramid. And then when you look at the impact inequality, so if you take the vulnerability of each group in the red bar, divide it by their contribution to carbon emissions, you find that the top 10% or the bottom 50%, each individual is 150 times more vulnerable to carbon emissions than the top 10%, who are the ones who are putting out 50% of the emissions. So there's a lot of inequalities there, and the reason I'm bringing this up is because of this linked actions from nature, economy, and society, that we have to really incorporate this justice element into actions in the future. So this means redistribution of wealth. So you can look at it as the share of carbon emissions should be fair across global society. You could look at it that way. So a lot of this, if the world was equitable, the total emissions from each of these 10 percentile groups would be the same. And then also the vulnerability, we need a lot of redistribution of risk from the lower income brackets up into the upper income brackets as well. And there are many different mechanisms proposed and are being discussed for doing this in terms of, restructuring the global financial system and so on. And I think what's really important here is that this work and the framing that we have around IPBES's conceptual framework and the sustainable development paradigm lays the biophysical foundation for this. So a lot of discussions happen around money and political power, but we really need to translate these into real sort of tangible things on the ground in terms of biodiversity and nature. And I think it leads to this, simple rule of thumb. The rules of thumb can be very useful and very important in helping guide action, just like the 20 to 25%, semi-natural vegetation per square kilometer. It's this 10, 40, 50 rule of thumb. You live like the middle 40%, you need to raise welfare in the bottom 50%, and enable this by reducing impacts and reinvesting from the top 10%. And that reinvestment, I've talked about it going into natural capital, of course, but of course it also needs to go into social capital in many places in order to deal with the justice issues that are outlined here. So this is covered in the transformative change assessment, which is coming out this year. And this is a very difficult topic to deal with. It's very uncomfortable for countries to deal with. We've had many comments on this report, and we'll see how well we can get this idea that these transformations in societal values are really critically important to go on sustainable pathways into the future. Not quite sure what I pressed there. Okay, there we go. The values assessment that we put out in 2022 presented a really interesting perspective on this. And I think this is really valuable in that it basically took the world that we look at, and this is the world, we all live in this world, very many different cultures and so on, and people with different value systems, but it really emphasized how we can have multiple different worldviews and knowledge systems, all looking into the same space. They identified these life frames of living with nature, living from nature, living in nature, with nature, and living as nature, and these sort of express quite different ways of interacting with and valuing different parts of nature. We've had far too much emphasis of living from nature, that's the extraction of what we've been doing, and balancing across multiple life frames would be very important. And then also these three main types of values of nature that correspond very well with the sustainable development model as well. So the intrinsic values of nature that align with the bottom, the instrumental values of nature that align with economic activities, and the relational ones that align very well with societal values as well. And I think these provide, it was a methodological assessment, so it's identified some tools that we can use, a bit like I think the conceptual framework and then the nature's contributions to people framework, and now this values framework may provide actual tangible mechanisms for decision makers to think productively about moving forward. So I'll come to my conclusions now. What does this mean in the biodiversity community? And I've come to this from working as a coral reef scientist and interacting a lot with the nature conservation community, so that's the NGOs and the funding that comes into that space. And I've been very frustrated by the lack of attention to the drivers. We've externalized the problems in a way, and we're focusing on the best places, and we're not looking at, you know, all the stuff that's coming in from outside, and not enough. And the strongest alliances in particular have focused it on, you know, iconic species, protected areas, 30 by 30 as a campaign, the last remaining places. This graphic from the Global Goal for Nature, I think, is a really problematic, it's very illustrative of yes, what we need to do, but I think going too far, and in that way undermining the work that needs to be done. And that's because from a justice perspective, we're not dealing with the root causes, which, as I've shown in the equity and justice graphs, really need to come from those who are consuming the most. And there's a multiple jeopardy in the remaining places where nature is most intact because they've had the least contribution to the global problem. Their resources are already committed, either appropriated or committed to in trade deals to go somewhere else. Their real opportunity cost to conservation locally. Finance is insufficient, as we just saw. And they're strongly disadvantaged in the negotiations, both in commercial terms, dealing with licensing for fishing and timber and agriculture and so on, but also in conservation as well. They're very, very weak in terms of being able to say what they want to happen. So to come back to this, to go back to these curves of how do we get from somewhere in this middle zone between the yellow and the black up to the green. These curves are really visions of plausible futures. We can look at how do we project we want to move forward into the future through them. There's that global goal, I think, is an implausible future. And I don't think it helps to have such a completely unrealistic sort of vision for where you want to go, where we really are over here is, you know, we're well below that curve already, if you're being honest about it. And there's no way of getting there. So we need to understand, so where we are now, we've already had a lot of conservation, which is good. This pedestal is there. We need to understand and maximize the true impact of direct biodiversity actions to get all the way up into the yellow on that curve, but then also to understand, to be realistic, to really understand the inertia and responsivity of biodiversity recovery so that we're not making unrealistic promises about what may happen based on grants or actions and so on. We then need to pay priority attention to direct and indirect drivers of decline. So this is the economic sectors and the financial sectors. Unless we reform those, you know, we won't be able to get beyond, you know, somewhere down in the grey to yellow zone. And then justice and equity, and this has to be a foundation because there's so many layers of injustice that have been those have been promulgated over centuries, that unless we redress those, it'd be very hard to balance this system, or probably impossible. So my last slide, just synthesizing this for thinking about ways to think about moving forward. So this is not answers, this is just a framework for trying to get to a better place. So on nature, we need to understand how it's a critical and primary asset class. It is the foundation for all economic sectors as well, even those that don't depend directly on it. We need to, conserve for its intrinsic values. We need to understand what to do to conserve, restore, and nurture it, and to return finance into nature. And I think that language is going to be important, to return, reinvest, convert financial capital back into natural capital. For economic sectors, to reduce indirect and direct drivers. This is sort of almost actions down the right-hand side of that model, perhaps. This is about instrumental values and about reducing consumption, reducing growth. Some places still need to grow, but many places don't need to grow anymore. And this really is a top 10% action of the first action needs to come from creating space in the top 10%. And then the society, the equity and justice actions that need to happen perhaps down the left-hand side there. This can relates to relational values, return wealth into nature, into natural and social capital. Again, that's a top 10% action. But then to equalize access and consumption. So some of the direct uses of nature, some will have to increase because many people have too little, but that space needs to be given by some uses decreasing for sure. And then this infinity sign is for transformations at the top. Who acts? I won't really talk about this, but there's many different actors across these different levels that have to act. I think we tend to be in the conservation and biodiversity science scene down here in the nature platform, thinking about our interests, but we need to think much more about producers, owners and stewards, communities and their interests, and how to negotiate amongst those, and of course up the other ones. And then just a final call out to the Nexus and Transformative Change Assessments coming out at the end of this year. They'll provide a lot more information on all of this in a different way. This is my own interpretation of how this fits together. But I think I can't wait for those assessments to come out and for us to use them in decision making. So thank you very much.